Okay, welcome to another fun-filled episode of geometry for you and me. Okay, section 4 of the chapter, we're dealing with inscribed angles. First thing we have to do is remember that inscribed means the vertex lies on the circle. That's the main part of it. This, okay, kind of looks like this. This is an inscribed angle. Yay! Okay? Angle ABC, or x degrees here, is an inscribed angle. AC is what's called the intercepted arc. Okay? So as the angle goes out, it passes through or intercepts that arc. Okay? Now, when we look about measurements, an inscribed angle, a measure of the angle itself, is half of the arc. So, x and 2x. If you want to think about numbers, if this is 30 degrees, that's 60 degrees. Okay? And the opposite is true. If we know that this is a 70-degree arc, that's a 35-degree angle. That's what we're looking at. Okay? Now, that's the only formula for today, but it takes several different forms. If you have angles or an angle that is inscribed and intercepts the endpoints of a diameter, remember diameter, half a circle is 180. So if the angle is inscribed in a half circle, then it is a 90-degree angle. Okay, that's just simple math, but it's like an additional thing that you can look at and see quickly and go, oh wait, that's got to be 90 degrees. Okay, which gives you right triangles as well. Okay, look at that moving forward. Okay, if we have more than one angle that intercept the same arc, okay, so angle E intercepts arc AB, angle D intercepts arc AB, angle C intercepts arc AB. Since they are intercepting the same arc, their measures are half of the same degree measure. So those three angles, E, D, and C, are equal to each other. Okay? So angles that intercept the same arc are equal. And finally, if you have a quadrilateral, we showed this at the first part of the chapter when I talked about inscribed. Okay? Because I wanted to make this point early. Okay? If you have a quadrilateral, a four-sided figure, inscribed in a circle, remember that means that each vertex is on the circle. Then, opposite angles are supplementary. Okay? Opposite angles are supplementary. Here's why. Angle A comes to this point and this point, so it intercepts that arc. C, endpoint, intercepts that arc. You've just intercepted the entire circle. Half of 360 is 180. That's why it works. That's how it works. Okay? So, let's do some problems. I'll get some pens. Talk amongst yourselves. Okay. Colors galore. Okay. The first ones. And once again, that bar of light at the top is really hiding nothing today. It just says find. Okay? So that's what we're going to do. Okay. This, here, here, here. Okay. So. Okay. First one, simple inscribed angle. the melodious tones of whatever bell we've decided to use. Okay? If that's 44 degrees, the inscribed angle is 44, so arc AB is 2 times that. So in this case, arc AB is 88 degrees. The arc is 2 times the angle. Okay? The arc is 2 times the angle. Yeah, some of this is just that simple. Okay? Here, we have a 90-degree arc. Find the measure of angle x. Half of 90 is 45. Okay? And here, if the arc is 129, half of 129, 64 and a half. Yeah, that's all we're dealing with. Okay? Those are the easy ones. Those are the startups. Okay? Now, we've got a problem here. I have 2 angles which are given to me in terms of variables. But what do we know about those 2? They intercept the same arc. So those 2 angles have to be equal to each other. Okay? So that's what we're looking for. Now, if this is 22, that is going to be 44. And that's going to be 44. Okay, so angle W, 22, excuse me, half of that. 2 more angles that form the same arc have to be equal to each other. Okay? Now we're going to find this. This equals this. Okay? There's your setup. We're going to solve for x. Now, yes, it does ask for the measure of angle y. So once we find the x, we substitute back in. Okay, so that becomes x equals 25. We substitute back, okay, replace the x with the 25. 2 times 25 plus 2 is 52 degrees. Okay? There's the next level of problem. Let's go over here. Okay, first things first. We want to find the measure of angle A and C. So yes, we have to find the value of x first. But to do so, let's think for a second. This angle is inscribed, notice the endpoints are at the end of the diameter. That means it's a right angle. So, we have a right angle. We should remember that the acute angles of a right triangle must add up to 90. Okay, just like that. Okay, solve for x. So, well, if x is 21, then angle C is 21. And you can either subtract from 90 or plug it in, okay, and get 63 and 6 is going to be 69 degrees. Okay? Not incredibly difficult. Once again, as I have said over and over this year, the math part of this is not difficult. Getting used to the setup of a problem, I can see that being a little getting used to. But even then, once you know your rules and you're comfortable with them, even that starts to become simple. Okay? Our last one. We have an inscribed quadrilateral, which means opposite angles are supplementary. And in this particular problem, this pair of opposites both have an x, this pair both have a y. That's all we're going to do. Because then we've got to figure out what angle G is. So once we find out x, we substitute back. And then angle H. So we're going to do that. Okay? We're just going to go alphabetical, I guess.
Oh.
Bugs. Stupid. Okay, we know opposite angles in an inscribed quadrilateral are supplementary. Okay, so that's where we're at right now. Okay, so we find the x is 9 and substitute back. And we get to 73 degrees. Okay, there's our answer there. Okay, now we're going to do the same process. Okay, same process for the y's. Okay, just set it up. Okay, and then remember it asked us for angle H, so we substitute back in there. Okay. Uh, 60, 42, 102 minus 4. 98 degrees. Okay? And that's the type of problem you can expect on your assignment today. Okay? Just what you've seen right here. Okay? So, thank you for watching, and I will see you either on the screen or in the class. See you soon. Bye.